Hello all, I am Siddharth Kaul and I welcome you to Edupedia world. In this video, we are going to take a look into numeric classes. Matlab has 4 signed and 4 unsigned integer classes. Signed integer classes enables us to work with both negative as well as positive numbers, but they cannot represent a wide range of numbers. Whereas the unsigned type does only works with the positive numbers and hence they can represent a wide range of numbers. The difference is in signed type, one bit is used to designate a positive or negative sign for the number. The unsigned types gives us a wide range of numbers, but these can only be 0 or positive. So Matlab supports 1, 2, 4 and 8 byte storage for integer data. So we can save memory and execution time for our programs if we use the smallest integer type. So for example, to store a value of 100, we do not require a 32-bit integer. We can work with 8-bit integer or a 16-bit integer. Hence, in the way we can save memory and we can speed up our program execution. So the table here shows the classes that are available, integer classes that are available in Matlab and the range of values, and also the corresponding conversion function that we need to use to convert other data types into this one. So creating integer data. Matlab stores numeric data as double precision floating point by default. That is double. To store data as an integer, we need to convert our value from this double to the desired integer type. So there are few points to be noted here. The first is that to store a double as an integer, we use a conversion function such as integer 16 or integer 32 or integer 8 as shown in the previous table. Second, if the number that is being converted to an integer has a fractional part, and if that fractional part is less than 0.5 or greater than 0.5, then it gets rounded off to the corresponding nearest integer. Say for example, we have a number like 325.499 that is less than 0.5, so it will get converted to 325. Similarly, if we had a number like 325.6, then that number would be rounded off to 326. But what in case the fraction part is equal to 0.5? In that case, Matlab chooses the value that is larger in magnitude. So when we have a number such as 325.5, then it can either be rounded off to 325 or 326, but Matlab chooses 326, that is the larger of the two values. Matlab provides us with an option to change the default rounding option. So there are 4 options of rounding available, that is round, fix, floor and seal. Each have a different style of rounding. Say for example, the fix function enables us to round towards 0 when a non-zero fraction part is encountered. So if we had a value such as 325.9, even though it is much closer to 326, the fix function will reduce it to 325. Arithmetic operations in integers. So arithmetic operation between an integer and a floating point always results in an integer data type. Matlab rounds the result when necessary. Say in this example, we have an integer 325 that is multiplied by a double, that is 4.39. The answer that it yields is 1426.75. This number is then rounded to 1427, which is then outputted as the final answer. The rounding off is done using the default rounding algorithm. The integer conversion function. Not only the integer convert function are used to create integer data, it is also useful when converting other classes such as double and especially the strings to the integer class. In this slide shown here is an example where a string that is nothing but a character array is converted to an integer. So the string hello world is converted to an integer. Each character is counted as a separate entity in this string, and for each character we get a corresponding integer value. So this character array is basically converted into an integer array. So here in this example, H is converted to 72, E to 101, L to 108 and so on. Even special characters such as space has an integer value of 32. One of the point, or we can say one of the more important cases that is related to conversion of integer is this. So there are certain cases or data points where we encounter NaN, that is nothing but not a number. So when this NaN is encountered by any integer conversion function, it is converted to 0. Whether you use a 32-bit conversion, 16-bit conversion, or an 8-bit conversion. There can be two conditions, or we can say two scenarios in which arithmetic operations involves integer. The case one is when both the operands are integers, means the arithmetic operation is happening between two integer data. So in this case, the result will obviously always be an integer. In the second case, that is when one of the operand is an integer, but the another operand is some other data type such as double, single, or character. In this case, the result will again always be an integer data type. So when an integer is operated with another type such as double, single, or character, then the output we get is an integer data type. The maximum and minimum values for the integer class. So for each integer data type, that is 8, 16, 32, and 64, there is a largest and the smallest number that you can represent with that type. To find these extreme values, we use the function integer max and integer minimum and pass them the integer data type as an argument. Here in this case, we are seeing the maximum value of integer data type of 8 bits using function integer max, and we get a value of 127. Similarly, we can see the smallest value of integer data type of 8 bits using the function int minimum, and we get a value of minus 128. The floating point numbers. Matlab represents floating point numbers in either double precision or single precision format. The default is double precision. The Matlab constructs the single precision, or we commonly say single, data type according to IEEE standard 754 for single precision. Any value stored as single requires 32 bits as shown in this table. So the last bit is a signed value, whether it's 0 for positive, 1 for negative. 30 to 23 bits are exponent, that is biased by 127, and 22 to 0 is a fraction f of the number 1.f. Similarly, Matlab constructs the double precision or double data type according to IEEE standard 754 for double precision. Any value stored as a double requires 64 bits. The format is shown in the table below. In the table below the single precision. So we have the 63rd bit, that is a sign bit, which stands 0 for positive, 1 for negative. Then bits from 62 to 54 are exponent, that is biased by 1023. And bits from 51 to 0 represent fraction f of the number 1.f. Creating floating point data. As discussed already, the double precision is default data type that Matlab uses. So to create a double floating point, we don't have to do anything special. We just define a variable and assign it a floating value, automatically making it a double data type. To create a single precision data type, we use the function single for type conversion. In this, we pass the floating number and the function converts that default double data type to the single precision and then assign it to a variable. Here in the slide, you can clearly see the class of the default variable, which is double, and the class of the converted variable, that is single. So arithmetic operations on floating point numbers. While performing arithmetic operations on floating point numbers with single and double precision, we have to remember one particular point. That is, what will be the data type of the answer. So on the left, I have highlighted the point for double. So when in an arithmetic operation, one of the operand is double and the another one is either double, character, or logical, then the result is always a double data type. Similarly, on the right, I have highlighted the point for single. So when in an arithmetic operation, one of the operand is single and the other one is either single, double, character, or logical, then the output is always single. Remember and do note the point that when both double and single operates with integer data type, the result is always an integer. That is why integer does not feature in this list. The largest and smallest value for floating point class. Like integers, double and single data type too have their own largest and smallest numbers. So in the first table, the range for double is shown, and in the second table, the range for single precision data type is shown. The double goes to the power of 308 and minus 308, whereas a single goes to the power of 38 and minus 38. Now we are going to take a brief look into complex numbers. Complex numbers are of form x plus iy or x plus jy, where x is the real part and y is the imaginary part, and I and j are imaginary unit which has a value of square root of minus 1. There are two ways in which we can create complex number. First one is as encircled in green, where we use the numbers directly with assignment number I or j to create a complex number. So 2 plus 3i says that 2 is the real part and 3 is the imaginary part. The second way is using the complex function. In complex function, we pass the real argument x and the imaginary argument y of the same size, and then the function returns the complex number. Using functions such as real and imaginary, we can isolate the real and imaginary part from the matrix of complex numbers. So the table on the right top shows how we can create a complex number using a function complex, and the table at the bottom and the box in the bottom shows how we can use the function real and imaginary to separate the real and imaginary value from this matrix of complex numbers. Infinity in Matlab. Infinity in Matlab is represented by a special value I and f. Infinity results from operation like division by 0 as shown on the top left, or by overflow as shown on the top middle, or by an logarithm of 0 as shown on the top right. So there are basically several ways that value can go to either positive infinity or to the negative infinity. But the thing is, Matlab handles these situations quite well. Matlab provides an is_inf function that returns 1 when the argument passed is infinite and 0 when the value passed is definite. NaN in Matlab. When there is a value that is not a real number or neither it is a complex number, Matlab represents such numbers with a special value called NaN, which stands for not a number. So basically, if something that is not a real number and it is also not a complex number is not a number. So expression like 0 by 0 and infinite by infinite results in not a number. Any arithmetic operation that involves NaN also returns an NaN. That is logical. The NaN function returns one of the IEEE arithmetic representation for NaN as a double scalar value. The exact bitwise hexadecimal representation of this NaN value is FFF0 followed by 12 zeros. Is_NaN function is used to identify not a number in a series of arrays. Logical operation of NaN is somewhat as seen in the rightmost box. Logical operation involving NaN always returns 0, whether it is greater than, equal to, less than equal to, greater than equal to, whatever may be the operation. The only exception to this rule is not equal to operation. The not equal to logical operation between two NaNs always returns a 1. This is the last section for this numeric classes. In this section, I will be very brief about the display format for the numeric values. So by default, Matlab displays numeric output as a 5-digit scaled fixed point values. But we can change how these numbers look into one of the 5 following ways. The first is we can have a 5-digit scaled fixed point, floating point, or we can have a best of 2. The second is we can have either a 15-digit scaled fixed point or a 15-digit floating point, or we can have the best of 2. Third is we can have the number in ratio of small integers like 2 by 3, 1 by 2, 8 by 10, something like that. The fourth way is we can display them as hexadecimal numbers, that is numbers with the base 16. The fifth is the bank notation that is helpful when we are dealing with the currency values. To change the numeric display settings, we use either the format function or the preference dialog box that is accessible from the Matlab file menu. The format function changes the display of numeric values for the duration of single Matlab session, whereas the preferences settings remain active from one session to next. So these settings only affect how numbers are displayed and not how Matlab computes or saves them. This concludes our video on numeric class, and in the next video we will take a similar kind of look into logical class and see how they are used. So until then, please subscribe and thanks for watching.